Seems like a bad reason to stay in Canada. Okay, I just unmuted it.
Yeah, and thank you everyone for coming today. And I'm so glad to invite two of my friends from University of Michigan and Penn University, and both of them are PhD students in the US, and and they are now working as a research intern at Microsoft Research Cambridge. And so Hank, he recently won the award from UNICEF's
UNICEF Kai.
Yeah. And she also won a lot of paper awards nominations from trials at CW. And so today they're going to share some research insights from their projects, and I will hand over to you.
Sounds good. All right. So yeah, thanks for the really kind introduction, John. And thanks again for taking the time to chat, especially during the really hectic deadline season. So, all right, I can switch to my slide here actually. There we go. So yeah, hi everyone. My name is Hank Lee. I'm a PhD student at Human Computer Interaction Institute at Carnegie Mellon University. So overall, my research interests at the intersection of usable private security, human computer interaction, and human-centered AI. So what that really means is that I advocate for user privacy in AI technologies. So things that I'm doing at Microsoft Research is a little bit differently, but unfortunately I couldn't really talk about it. So I guess the things I'm talking about is mostly my work in Carnegie Mellon, where we try to create tools and methods to help practitioners who are building AI technologies to think about privacy. And yeah, feel free to interrupt me if you have any questions, or we can also take more questions at the end of the presentation. Right, so now we're in the era where artificial intelligence is part of our everyday products and services. And the recent work in AI asset design materials has looked into ways to systematically support practitioners in using AI to idea new AI products, right? Indeed, these shiny new AI technologies make the world very exciting, creating many new technologies and product opportunities. But there's a flip side, So new privacy risks introduced by these AI products as well. So we're seeing the privacy incidents caused by AI products on social media. They remind us that without careful consideration, these AI products can also turn into large-scale unsupervised surveillance infrastructure that intrudes our privacy. So the tension between utility and privacy or intrusiveness of AI interests us to take a closer look at, one, how does AI change privacy risk? And second, are practitioners who are building these shiny new AI technologies equipped to recognize and mitigate the privacy risk introduced by AI? And building on these foundational works, we're now building a tool to help practitioners raise the awareness of privacy risk of the AI products they intend to build. And these are basically the three main things I want to talk about in this presentation. Hopefully we could cover all of them here. So let's start from the question of if AI indeed changed something about privacy. So to answer this question, we created a taxonomy through a qualitative analysis process. So to keep our analysis or process grounded in reality, not speculation, we scope our analysis to cases of privacy incidents or harms related to real-world AI privacy incidents. So we source these from a popular public AI incident database called AIAIC. So AI AIC is a curated database of over 1,000 incidents where AI caused some types of harms. For example, harms related to privacy, fairness, or transparency. And over 300 of these cases were tagged as being somewhat related to privacy, at least at the time when we conducted the analysis. And we manually analyzed these cases to see if the privacy risk described in each instance was either created by or exacerbated by, or otherwise not meaningfully changed by AI. Specifically, we ruled our analysis against Solof's popular taxonomy proposed in 2006, which we use as a baseline to capture privacy concerns and tell by computing more generally before the modern advances in AI, right? So if solid taxonomy captured the privacy risk described in an incident in a manner where the modern AI or capabilities of AI or requirement of AI play almost no role or very little role, we say it was not meaningfully changed. On the other hand, if the risk described appeared to be different than what was captured by solid taxonomy, we ask if the risk here fundamentally new in some way, or were the requirements or capabilities of AI exacerbate the risk that we already known about, right? So very briefly, we identified 12 types of AI privacy risk and found that 93% of them involve situations where the capabilities or the requirement of AI either create or exacerbate the described risk. So we also created a website at aiprivacytaxonomy.com to increase the reach of our work. But in this presentation, I will highlight a couple that we listed out in that website and presented here. So let's first talk about risks that AI exacerbates. So these are risks that have always existed, but AI can extend the intensity or scale. First, of course, surveillance, right? Which is always a big concern when we talked about computing technology that constantly watching, listening to, or recording an individual's activities. So surveillance had long existed before AI, but AI exacerbates the risk by incentivizing the collection of ever more data, or train and deploy effective models, basically. So there are reports, for example, schools that deploy student safety management tools to detect and prevent violence and suicides, but in monitoring students' digital footprints like emails, online documents, internet usage, or even social media accounts. Or reports in which employee geolocation data from mobile devices were used to assess their performance, raising concern about employees tracking even outside of their work. And these examples of surveillance of increased scale and ubiquity are incentivized by the promise of AI being able to sift through this data very easily. And second, identification risk, another well-known privacy risk, I would say, entailed by AI, refers to linking specific data points to an individual's identity. For example, a picture of you or your face may not link to your identity by default, but with the facial recognition technology, it's more easily to do so. And AI technology can automate the identification process, looking across different sources and large scale, and often in real time, and even with low quality or obfuscated data. So example of this is Clearview AI, a facial recognition software that allows police to index of your online presence in real time, which is a photo of you, even when you're wearing a hat or glasses in the photos. AI could also exacerbate insecurity risk, which refers to the carelessness in protecting collective personal data. So AI can exacerbate insecurity beyond being bad steward of personal data, for example, being hacked, right? And large language model can memorize training data, for example, and reveal sensitive information of a user to other users given a particular prompt. For example, a chatbot trained on real-world text conversations was found to expose information like the names and home addresses of a user whose data on which the bot was trained. All right, so let's switch gear and talk a bit on the risk that AI creates. So we found that AI can create two types of new risk, new instantiation of known category risk and new category risk. So one new instantiation of risk is in distortion category, which refers to disseminating false and misleading information about people. The one that we typically hear of is misinformation through deepfake, which exploits others' identity to generate realistic fake images and audios. Fortune users, for example, was found to use deepfake technologies to create audio of celebrities saying homophobic or racist things that they had never said before. There are also AI-exacerbated distortion risks that are less egregious. A filmmakers of the documentary used the fake to create scenes of an actor who had passed away for lines he had no recording of. So this example also raised important questions about expectation about privacy in light of how generated AI should and can be used in different use cases. And finally, we found there's a new category of risk that wasn't well captured by the original solid taxonomy that AI can enable. So phrenology and physiognomy. Physiognomy is a pseudoscience that purports that one can understand a people's characters or personality traits, like their intelligence, likelihood to commit a crime, simply based on the physical features like their face or body. And in our data set, we found attempts, for example, to use AI to classify people as gay or straight, or whether they or not they are criminals based only on the picture of their face. And beside the problematic use of AI, of course, these also raise privacy concerns where user-sensitive information is being inferred and potentially being shared. All right, so hopefully our taxonomy provides some evidence in terms of why we think AI appears to change privacy in some way. Then the logical next steps for us is to try to understand our practitioners who are working on these AI products and services equipped to recognize and mitigate this AI exacerbated risk. And there are reasons to believe that AI technology can create challenges and create new challenges for practitioners to think about privacy when building products, besides the privacy harms due to its capabilities that we just mentioned. Specifically, prior work suggests that there remains a substantial gap between principles and practice in creating AI technologies that center human needs, societal good, and safety. And here we zoom in specifically in the aspect of privacy, right? Even for well-known resources for design AI systems like Apple's human interface guidelines for machine learning and Google's peer guidebook, it is unclear if they provide enough guidance for practitioners to directly follow through for their privacy work. And to formally contextualize the actual barriers that practitioners face in AI privacy work, we drew from the Security and Privacy Acceptance Framework, or short for the SPAF. So the SPAF survey on what leads to users accepting or rejecting best practices about privacy and security, and identify and summarize that there are three key barriers that user has overcome: awareness, motivation, and ability. So we apply the SPAF and take a closer look at whether practitioners have the awareness of the potential privacy risk that their products can entail. Second, the motivation to act and address the privacy threats, such as taking action to mitigate or at least having some discussion about such a risk of their products. And finally, the ability to convert privacy intention into action. So let's say the practitioners identify the risk and decide to act on the risk. Do they have the ability and the right tool in doing so? We pose three research questions corresponding to each of the SPAF barriers that we just talked about in terms of, first, how well do AI practitioners' definition of privacy work reflect the awareness of AI-exacerbated privacy threats or risk? Second, what motivates and inhibits privacy work for AI products? And finally, what affects practitioners' ability to do AI privacy work for AI products? So we interviewed 35 industry practitioners with all kinds of roles from different technology companies of different sizes and domains to understand their current approaches to privacy work. And all of our participants have participated in discussion about end user privacy as it pertains to the products they build. So what do we find? So first, when defining privacy, practitioners often use the language of harm reductions and mitigation. For example, Ategli talk about his team's approaches to training privacy-respecting machine learning models as not being able to pinpoint behavior to a single origin. But software engineers, on the other hand, stress the importance of not repurposing the data set collected from users other than their initial goals. And another practitioners describe the need to ensure the user data be protected in the whole AI product lifecycle. So seeing these, you may wonder, nothing have really changed compared to the privacy for non-AI products, right? And indeed, our participants were not really aware of how the capabilities and the requirements of AI might change the privacy threats entailed by the products. And here's an example. Well, a lot of our participants' products involve a language model, which is probably not surprising. None of them mention the memorization issues in LLM, which can accidentally reveal sensitive user data to other users that we just talked about, right? And in terms of motivation, we identified key motivators and inhibitors for AI privacy work. So first is the alignment with business interests. So our participants discussed competitive differentiation and client concern as key motivators for privacy-related design deliberations. Some of them also talked about social responsibility. Specifically, they do not want bad use cases of their machine learning products to be inappropriately applied to the real world. And finally, many practitioners mentioned complying with external regulations like GDPR as a general motivation to act on privacy. But we also found more inhibitors for practitioners' AI privacy work. I'm going to share some of them here. So first is the rigid compliance. And indeed, compliance with privacy regulation can motivate privacy work. However, we also found that compliance-driven approaches to privacy sometimes also prevent them from going beyond minimum requirements. And second, practitioners also express a lack of career incentives or even indirectly misaligned with such incentives. And finally, there were opportunity costs. Our participants discussed how privacy work comes with the trade-offs that make it difficult to prioritize. For example, the trade-offs of model performance entailed by these AI privacy work. So a key upshot of practitioners' motivation for privacy is that their privacy work is most commonly driven by meeting these non-AI specific compliance standards. And that practitioners currently face many more inhibitors than motivators for privacy work in developing AI products, and thus have a low overall motivation to engage in privacy work beyond minimum requirements. And finally, we want to understand ways that translate practitioners' intention about privacy work into actual actions. So our participants described using a range of methods, artifacts, and resources in their privacy work for AI products. And I will talk about two more common ones here. So first, it is common that there are some type of company-wide privacy trainings to educate them about privacy. However, such trainings were often generic and not directly related to the products they are building, specific AI products. They also reference on-demand design documentations and consult the privacy or legal aspects when designing for privacy. But overall, we found that practitioners face ability barriers in their privacy work. Specifically, AI systems are complicated, and it's really hard for them to sort of understand about the privacy issues that could result from the data they collect and process. Also, practitioners often found it challenging to navigate privacy requirements when building AI products. Specifically, the ways to make sure that the AI products complying with those compliances were often too new for the organization to have some prior experiences. So in general, practitioners were not well prepared in terms of tools, resources, and support to design for privacy. Instead, they focused mostly on following compliance's rules and had to put in work to understand how these rules apply to specific products that they're building. All right, so our work so far opened up a design space for supporting privacy work in AI. And moving forward, we're envisioning how we could design and create tools for practitioners to foreground privacy risk introduced by AI. Specifically, we now know that practitioners are ill-equipped for privacy work and do not have tools to help mitigate AI-specific privacy threats. So we're now looking into the space of AI-specific privacy design assessments and design tools. For example, work in human-centered AI has already begun to explore approaches like checklists, model cards to help practitioners explicitly foreground principles like fairness, transparency, the design of AI products, right? We thought that the similar artifacts could be also created to help practitioners design for AI-specific privacy threats as well. So to that end, we're currently building a system called Preview. So to help practitioners to identify privacy risk in their AI products and service ideas that they intend to build. Very briefly, so through Privy, we want to demonstrate a possibility where practitioner can first identify key use cases and associate beneficiaries of the product idea. And then also identify potential privacy victims associated with these key use cases. And finally, try to organize and prioritize different use cases, specific privacy risk of the AI product ideas. Yeah, so I actually have a working prototype. Just in case any of you have interesting give system a shot, we could also do that and check more later on after the presentation, I guess. And I guess this is pretty much all for me. Thanks again for your attention. Yeah, so the use cases for that is so we have some like collaboration with some industry folks specific and some startup like using AI to realistic products. And also based on our experiences when we talk to practitioner, one of the challenges they face is, we actually try to present some of the work we've done at CMU and present to them, hey, this is a taxonomy of AI about privacy. What do you think about it, right? So most of the time their reaction is like, oh, this is cool. It could be useful, right? So, but when we dig a little bit deeper in terms of, can you like come up with some, sort of like reasoning, or through by reading these taxonomy, could you try to apply that to their products? One of the challenges that we encounter, or at least that we observed, they have some issue with is to contextualize the product idea they had to these taxonomy, right? So, like the idea here is that if you give me a product idea that you want to build, could I just directly give you some contextualized example in terms of how these products could be potentially privacy intrusive? So what we actually do is using Gen AI to basically do some prompt engineering, some magic black box to basically use our definition of privacy in the privacy taxonomy, as well as the databases that we have in terms of how the real world cases, those news articles describe those privacy intrusion, and try to provide some contextualized description in terms of how these privacy taxonomy could be applied to your product. So for example, let's say you want to, build an algorithm to say, give me your social media post. I could help you to predict, let's say, predict the potential audience for that post, right? There could be a potential risk, let's say, in terms of inferring your political views or your gender identity by accident, where, end user may or may not are aware of it, and maybe you want to address it, right? So in a way that potentially we could build a tool like this, give me the product idea you want to build, and I could help you to foreground in terms of what type of privacy risk you may want to sort of concerned about. And the angle here is that by foregrounding those privacy intrusions scaffolding process, it could be potential way of engaging a discussion where this is a utility you want to provide to this product, but this is also the flip side in terms of privacy risk, and whether this kind of conversation can also lead to potentially a more privacy preserving AI products. Hope that answer your question in terms of the mindset of that. And the interaction I show is basically one of the way that we're exploring in terms of what will be the way of presenting those information to practitioners. And we actually just running use stuff for that. Yeah.
Yeah, follow-up question.
Yeah.
So what kind of like format of the input, is that only text-based?
Currently it's a text-based, yes. But there are also like some of the multi-model approaches that we're thinking of. But at least for the initial prototype, we're probably just thinking of like the text-based approach.
Okay, so you said that the product, then it's the description of the product.
It's a description of the product, yes. Yeah. But we also
details that should be.
Yeah, so there's additional scaffolding process, but the basic hypothesis here is that the product team normally had the idea in terms of what is the angle for the product. For example, what type of feature you want to build, what type of input and output the model is. So based on that, based on our at least initial prototyping process, it's good enough to at least provide some contextual info for practitioners. Yeah.
So you mapped out awareness, motivation, and ability as these categories of various. Which ones this pretty interesting?
That's a really good question. So previous actually try to attach with the awareness and potentially move a little bit toward ability. So ideally, my PhD thesis should be like 3 systems for each various, but that's just the goal. But ideally, there'll be 3 systems like line up.
Because I'm wondering, I guess, more about the ability
Mm.
part of it.
Yeah.
How would you solve this? Right?
Yeah, that's a really good question.
There are good concerns that the people were facing.
Yeah, so one of the things I'm thinking about right now, at least for the ability, right? I do have some sort of like thoughts in terms of motivation and other stuff as well. But at least for the ability, something that we observe right now is we want to potentially provide the local database in terms of different ways of approaching privacy risk. So some context here. So when we talk to practitioner, we actually realize that there's a lot of like internal documents in terms of how, let's say Microsoft, for example, there are some internal document where, some requirements, libraries or tools that you could actually use provided by the company level, but not all of the practitioner are actually aware of it. So one idea that we had is potentially map out those pathway in terms of, hey, this is the privacy risk that we help you to identify. And this could be a potential approach in terms of solving that based on the company internal databases or resources that you have, right? So in a way that instead of creating new resources for practitioner, whether we could actually try to collect the existing resources and potentially create a pathway for practitioner to solve that potential problem. So that is like really abstract level, but so like the way that we're thinking about it right now is instead of like creating new resources, can we map out the existing one? And if that's the challenges, then we could probably argue that, hey, we don't even have the proper resources to, in order to address those, right? And then there could be another thought in terms of, hey, maybe we need something new here. But yeah, just like really abstract level, but hopefully that answers your question. Yeah, go for it. Mm.
So why would you to math rather than learning textual-based?
You mean textual base? Yeah, we tried the textual base actually. And one, it doesn't really work. I think there's a lot of like question in terms of one, practitioner doesn't really like to read. They want to do something about it, right? So even you want to present information, at least make it more playful or at least make it more interactive. So this is sort of like the idea that we come up with. Like we still want to present those information to practitioner, but can we make it in a way that they could engage more in the process? And why this specific format? There's a lot of inspiration. And one of the, in case that you are aware of the paper called Farsight in this year, Kai, this actually drew a lot of inspiration in the block programming. I think that's a terminology for that, like block-based programming. I think we actually drew a lot of inspiration from that community in terms of how we could create interfaces that is interactive, but at the same time could be engaging to the people that are using those information. This assistant, especially when you are trying to present some really text-rich information, right? Hopefully it works, but I don't know. But at least based on our pilot study, people like it. So yeah. Okay.
Great. Thank you very much.
Thank you. So you may want to turn off the camera.
I'm not sure if like the people in online can see the screen or not. Okay, yeah, sure. Okay, yeah, hello everyone. My name is Xinyue, and nice to meet you guys. And I'm so glad to be here to present my some of my work, which was done like mostly in last 1 year, like 2 years. Yeah. So yeah, like I think it's just some connection from what just Hank's the tool Hank just designed, and the last question I asked. So it's about more about like the why we want to put the textual information into like map-based information. And here today I will just present two tools we designed in terms of using AI to help people to uh, to be actively participate in their meetings and to do some like sense making task in group meetings. And one is more like textual based and one is more like math based. And after that, I will talk a little bit about a framework designing for using leveraging AI to support participation and sense making in group meetings, which can also balance well between the cognitive engagement and also the user agency cognitive engagement. And balance that with the AI automation. Yeah. So just some background. With the rise of the remote work, people hold more and more group discussions through video conferencing, yet they come with challenges to support students to actively participate in the conversation. So you may experience some difficulties finding a good time to share your thoughts, and you may find it easy to lose a context or get distracted during meetings, and which make it really difficult for you to effectively contribute to the conversation. So to support active participation, existing video conferencing platforms provide some concurrent feedback features, such as chat or reactions. However, those chat messages are not embedded in the conversation, which means sometimes we may just go over the conversation topic, and here might be a chat pop out. But in the end, we found like when we notice the chat, the conversation has to go to another topic. So how can we contextualize the concurrent feedback to discussion content? Transcript has been used in existing meeting platforms to help people to review and keep up with the conversation. However, prior work also shows that searching and navigating on the transcript during a conversation is really tough. So we conducted a formative study here to answer when and how people want to use transcript-based interaction to engage in discussion. And we employ some storyboards and a speed dating approach to explore how attendees might interact with transcripts. And we summarize the challenges of using transcripts as an extra communication space in project video meetings and propose the design requirements here. So here are 4 challenges mentioned in the form study. The first one is the readability of the transcripts. It's not good enough, and we want to enhance the readability to better align with the conversation flow. And second, users found transcripts were not interactive enough. So we are introducing diverse methods to help people to interact with them. And the third one is reading the full transcript in real time was a challenge. So to support this, we want to focus on displaying only the most vital information during the meetings. And lastly, people found it is difficult to locate specific information within the transcript. And we are simplifying the navigation and making it easier to pinpoint the desired content during the meetings. So based on those design requirements, we designed MiScript. This is a system that provides transcript-based interaction to support active participation and understanding in video meetings while not adding too much extra cognitive load to users. And MiMap first shows the transcript in a chat-based interface. And it supports 5 interaction options on each transcript bubble. Users can first highlight, like, comment, and tag on each transcript bubble to give some contextualized feedback. And users can also edit a transcript to if there are any AI errors. So since the full transcript is found as long and verbose, we designed mechanisms to keep the most essential information on the screen. So we deleted transcript bubbles without any user interactions after a time threshold. So to help users to easily navigate on the transcript, MiScript provides an interaction heat map. The interaction heat map is updated in real time, which realizes the density of the interaction on the transcript bubbles, and users can see the heat map to quickly navigate on the transcript. Besides, MiScript also provide an interaction history panel to locate the information more easily. So through this, users can interact with the transcript as they are discussing and asking some contextualized questions, and also simply navigate to the information that they want. So after go over what the system is like, let's come back to the problem we mentioned before. People don't have enough opportunities to participate and cannot keep up with the conversation. So can this system support them during their meetings and solve those challenges? So to answer those research questions, we did an evaluation study with 80 users with 3 conditions. People either discuss in Mitscript or Zoom, and another condition is Zoom with Otter AI Open, which is another like transcript service. So like the differences between the Otter AI and Mitscript is that it didn't has any mechanisms to navigate the transcript and reduce the length of the full transcript during the meetings. So it's just show the full and verbose transcript, but people still can make some simple annotation on it. So first, we assessed if Mitscript can introduce additional participation. The results shows that users in Mitscript had significantly more non-verbal interactions than those in both Otter AI condition and Zoom condition. Is that they have more non-verbal interaction is because they have talked less in Mitscript, and the answer is no. We examined if Mitscript compromise verbal participation, and we grouped this by counting speech terms, words spoken, and average speaking time in each person. And the finding indicate no significant differences across conditions. And while the above analysis showed that Mitscript boosts non-verbal interaction, our users perceived those transcript-based interactions as valid and valuable contribution by themselves. And we show some survey results which indicates that Mitscript users felt a higher perceived participation level of their team. And when comparing Mitscript to Otter AI, users believe that Mitscript's transcript-based interaction helped them to voice their opinions just based on the transcript. Then, will people consider higher understanding level by themselves? We also compare the survey questions that related to users' understanding level, and the results shows that the transcript in Mitscript beneficial more for understanding ideas and resolving misunderstandings, and also reviewing discussions in contrast to users in Otter AI condition. So after this study, we plan to run a deployment study with this system with some students' teams in classroom. However, we faced many challenges when deploying this tool at scale. So the first challenge is we found that the transcript was not an ideal representation of the conversation to support real-time sense making. For example, students face challenges in understanding the inherent conversation structure, and even with the information reducing mechanism we designed, they still feel like their cognitive burden in reading the transcript is really high. And second, users will just trust that AI will record the meeting for them using the transcript. And then this also like makes them to be less focused and not have the motivation to participate, to like actively engage with the conversation. And compared to provide more space for students to participate, they express their first leads to understand the conversation at first and build common grounds with each other so that they are able to contribute to the conversation. So to support those needs, we just continue this work to another system. We just do another study which called MeetMap. So in this work, we generate dialogue maps as real-time shared representation of discussion for collaborative sense-making in online meetings. So why building shared understanding and making sense of the conversation is hard? One reason is that the turn exchange happen in rapid succession in synchronous discussion and progress chronologically, which doesn't align with how ideas emerge and people process information in their mind, which is non-linearly. So a formative study with 8 users help us understand how people make sense of the discussion during meetings. And we found users first process information following a chronological order, and then they structure them to reflect the bigger picture of their meetings. And this information should be presented on the shared representation in real time to help them to make sense of those information. So we further derive 4 design goals for using AI to help collaborative sense making through shared representation. And the first one is enable them to create the visual representation assisted by AI. And the second one is provide both chronological and graphic representation of the meeting content. And the third one is categorize conversation terms with notation schema to reduce their cognitive load when processing those extra information. And the last one is to visualize the collaborative dynamics and provide more contextual information when designing to help them to be able to process the information in real time. So to support this, we introduced MeetMap, an AI-assisted collaborative note-taking system for meeting participants to collaboratively create dialogue dialogue maps in real time during online meetings. So MeetMap adopts a notation schema to categorize terms in the conversation as question, idea, pros, and cons, based on a frequently used meeting facilitation tools techniques called dialogue mapping. So the MeetMap user's interface contains a topic timeline panel, which displays turn exchange and conversation topic in chronological order. And the core of this system is a map canvas, which contains a temporary node palette and a map canvas area where users can collaboratively create dialogue maps. And a little bit more details about the map canvas. First, the temporary node palette displays AI-generated summaries of users' conversation as notes. For each detected term, it is sent to GPT-4 to assign a tag based on the dialogue, based on the notation schema, and then generate a short summary of this term. And the output will appear as a node in the temporary node palette in real time, following a chronological order. So it's kind of just a summary version of the transcript. Then participants can drag and drop the nodes to the map canvas and connect the nodes using links and create dialogue maps. Users have the flexibility to edit the content in the nodes, change the notation category of each node, and create new nodes manually. However, when introducing AI into students, into those conversations, the assistance dilemma is mentioned in our formative study. Participants can actively organize the information and create shared representation that may better reflect their shared understanding of the team when they make the shared representation by themselves. But they may also experience a higher cognitive burden to balance listening, speaking, and note-taking at the same time. On the other hand, when notes or meeting minutes are generated by AI, people can have more capacities to contribute to the discussion, but they may also lose the hands-on opportunities to participate. So to explore how much AI assistance is needed, we implemented 2 variants of MeetMap system. The first one called AI Node and the second one called AI Map, with different levels of human involvement and AI proactivity. So in AI Node, AI only generates the nodes, and users will create the maps by themselves. And in AI Map, AI will just produce this kind of dialogue maps when users are discussing, and users can make edits if they want. So we performed a within subject study with 20 users divided into 10 pairs, and each pair of participants experienced all 3 conditions. And in the third condition is like a Zoom condition, which we also use in we also open a transcript-based interface, and here is a panel for users to see the task. So they had a 30 minutes discussion on each condition and on the same decision-making task, and after which they will do some survey. So the finding of this study shows that users found Mimap more beneficial than the baseline for real-time conversation comprehension and collaborative sense-making, and the flexibility to visualize structured conversation was highly valued. And this study also gives us some insights on how to leverage AI to support sense-making in synchronous meetings that will not compromise human cognitive engagement. Firstly, our users demonstrate a clear preference for utilizing AI node during real-time conversation. This real-time assistance from AI allows participants to maintain their cognitive capacity. Notably, in condition utilizing AI map and traditional Zoom meetings, participants prefer to reserve AI support for post-reflection rather than in-meeting support. The distinction here emphasizes the value of AI synchronicity and its impact on the flow of the conversation. Moreover, the presence of the AI-generated content lessened the feelings of confrontation. Users report feeling less aggressive when it comes to refining and adjusting shared notes generated by AI than by their peers, indicating that AI's assistance fosters an environment of collaboration and co-ownership. Finally, our users also expressed a strong desire to be cognitively engaged. They want to retain control over the structure of the discourse. And the involvement of human agency is really crucial for them, despite the additional efforts required. So in conclusion, both Miscrypt and Mimap system shows that integration of AI in group discussion is not just about automating tasks. It's more about how to augment human participation and cognitive engagement while not being overwhelmed by extra content introduced by AI, and still keep the ownership and user agency on the communication activities. So we just come back a little bit to the systems dilemma we mentioned there, and think about how the current design of the Miscrypt and Mimap. So in Miscrypt, AI will just try to realize all the conversation, and people may just over rely on what AI generated. And although they will have interaction with AI, but still they might not try to cognitively engage in this process. Similarly, in Mimap, in AI node, where users can actively engage with the co-creation process, they might feel more control over the structure, which makes them feel like have higher cognitive burden, but at the same time, they may feel higher like cognitive engagement during this process. However, when they receive more AI assistance in AI map, they might lose the hands-on opportunities to interact with it. And then they may just take this as some extra assistance during the meetings, but they may choose not to read it during the meetings. So following on this, we introduce a framework that articulates a balance between AI assistance and cognitive efforts during synchronous and streaming communication. So how AI assistance, so we categorize people's sense-making process during note-taking in synchronous meetings as two stages. The first one is representation creation, and the second one is representation interpretation. So so without AI assistance during the representation creation stages, individual will identify relative information, organize it, and adapt it as discussion evolves. And in the representation interpretation stages, they will just comprehend the shared representation and utilize it to further guide the discussion by themselves. But when AI is introduced, it can automate tasks in the representation creation stage, such as generating meeting minutes and videos. And in the representation interpretation stages, AI can prompt meaningful discussion. However, the reduction in cognitive engagement during the representation creation might make interpretation more challenging. So we built a framework to discuss this nuanced interplay between AI assistance and cognitive efforts of sense-making in synchronous communication. And the core of this framework is to find a balance that maximize the benefits of AI in reducing the manual burden of representation creation, while also ensuring that users remain sufficiently engagement to effectively interpret and make sense of the representation. So as it is illustrated in this figure, the desirable AI assistance should reduce the overload while maintain or increase the optimal load that is beneficial for understanding. So thanks for listening, and that's my welcome for any questions.
So the first one you mentioned that in the AI node,
Yes.
they use GPT to summarize the sentences and you just generated
Yes.
budget.
Yes.
So how would you balance the simplicity and the accuracy of the user? Work?
Yes, this is a really good question. So basically, we're using like the turn-based mechanism where like after each turn exchange, we will send the summarization to the we'll send the transcript to the backend, and we ask the AI to generate a short summary. So we test this for many times. So at the beginning, AI will try to kind of summarize in a not that concise way, but in the end, we found because people have like really like limited bandwidth to read the content during their meetings, so we have to sacrifice the length of the length and accuracy of the summarization to be in a more concise way. So in the end, we just tell AI, okay, just summarize under 8 words. Like give it a limit of the words. Yeah, this is something that we do
Yeah, I think
here.
that's especially in the meeting.
Yes.
The users can catch up the details after the meeting.
Yes.
AI probably can provide original transcript maybe, but
Mhm.
yeah. My second question is in the AI map. The links are like automatically generated. Right?
Yes.
So
Yes.
how's the
Mechanism.
mechanism of this
Mhm.
generation, and how are they like accurate enough, or in
Yes.
conversation people may like
Mhm.
restrict the
Yes.
topic,
Yes. Right.
and how would your system manage this?
Yes. So yeah, so I think this also like experienced a lot of iteration here. So at the beginning, we were trying to generate a big map for like a comprehensive map for the whole meetings. So it's for like we first generate the nodes, and then we will also like generate like topic for the like identify the topics exchange happening in the conversation, categorize each term with a topic, and then try to merge some conversation related to the previous topic into like the same like same tree, like the different levels. But then we found also again people don't have the enough bandwidth to read the full map. And in the end, we try to like chunk it as like a small tree. So the mechanism here is like here we first generate the nodes, which is almost in real time. So people have a sense of okay, AI is working. And then in the backend, we will identify if there is any topic exchange. If yes, then we will process the previous several terms for the previous topic and then try to generate a small tree for that topic. And then we give the users the agency to, for example, create bigger trees, link between different trees, or just delete any errors AI may make. Yeah, this is something. Yeah, this is a current mechanism, but I think there should be some other improvement we can do in terms of how to make this more accurate. But from our user study, I think, yeah, this is something really interesting. So in AI node, users are really care about the accuracy of the nodes. So they will just, for example, they will edit the categorization here if it's wrong, because they have the responsibility to build the map by themselves, so that they are really care about the like the quality of the outcome of the map. But in AI map, because AI do those things for them, so they didn't mind much about the accuracy of AI. So they just say, okay, this kind of makes sense, and then it's okay. So and we think this is really interesting. Like people might have more tolerance for AI's error if they have less interaction with them. And I think this also echoed with the framework we propose, because people like have less cognitive engagement, so they might didn't like have enough immersive experience and thinking about what is the inherent structure behind the map generated by AI. They just think, okay, this visualization might be helpful, and they will just take a glance at it, during the meetings. But in AI load, they will just generate some guiding notes and using this to guide their discussion and to check, okay, if our current discussion is aligned well with our overarching goals, and if we are in good structure. If we in one tree, if we talk too much about like the pros but less about cons, so yeah, they will have more thoughts in this area. Yeah.
Yeah, follow-up question.
Yeah.
I have to give up.
Go ahead.
So, follow-up question is, have you tested the evaluate the outcome, like the third person who are not in the meeting, or someone who are in the meeting but not generating the graph?
Yeah. So our current study design is more like we recruit two people to have their meetings in real time, and then during the meetings they use these two tools. But we are also thinking about like using this for, let's say, like the post-meeting review or reflection. Yeah, I'm not sure what kind of findings we can know.
Yeah. For that, I mean, for third person, they don't have the, let's say, agency
Yes.
to the graph. So
Yes.
it can have a more like objective view to the results.
Yes, yes, I agree. Yeah. So yeah, I think the current study didn't evaluate the overall quality of these two maps because it's kind of subjective. So we cannot say, okay, this map is better and that one is less. Yeah.
At the end of the day, we want people can use the output of the system.
Yes.
If it doesn't make any sense for like other people or for the people who are attending this meeting, that doesn't make much sense.
Yes, yes, I agree. I think at least for people who are attending these meetings, both are making sense for them. But I'm not sure how other people will react to it. Yeah. Yes, so we recruit people, mainly recruit from school, and then the students will come to our office and we will assign them to two different rooms and having video meetings, because like there are some issues with speaker differentiation. So yeah, through this they can just discuss, and at the same time they can collaboratively working on the map. Yeah.
That's the obvious question. What do you think happens when the meeting grows? When there's more than two people? Sense making.
Yes.
People not participating.
Yes, yes. I think, yeah, we have some really interesting finding in terms of the collaborative patterns on the map. So just for two people, there are already some like different how different roles and how different kind of maybe personality will influence how they want to interact and how they want to understand those information. For example, in some of the group, one people will dominate the creation of the AI of the map. Like he will just mainly for create all the nodes and try to merge all the stuff during their discussion. But maybe another one will try to edit the existing map by the end of the conversation. This is something happens in just Diet's conversation. And they also mentioned, okay, if there are more people here, it might be maybe a mess. If like, let's say for now, we just generate nodes in different colors. So like the color represents different people, but they will feel, okay, if we have more people, how can we identify who is who? And also like when they create the map, they also don't know, okay, who is working on this part and can I edit this part or not? But I think one interesting finding here is like if it's all of the map is generated by AI, then they will feel less confrontational to edit the things because they feel okay, this is not something that created by my peers. So I'm okay to just make any edits. Yeah. But in AI now, when the map is created by your team members, there are more like tricky and nuanced thoughts of around the collaborative patterns on it.
Do you think, well, sometimes we want to have a meeting just to discuss something like a recent project, but sometimes, for example, if I want a startup, sometimes my boss just want to assign me a task. So we are not discuss something, he just assigns something to me. So you think it will change the motivation of using such a system?
Yes, I
And
think so.
The features of the, yeah.
I think for this one, I think it's more it's designed more targeting to the meetings, like discussion oriented, and for example, like brainstorming meetings, decision making meetings. But if like it's more, if a meeting has more like hierarchy, and for example, if you are just assigned to do something, I think that makes sense for having this map here, because like I think the end of the goal is to support them to understand and make sense of the information itself. Yeah. Okay, thank you.